Alright, so number 7 from the practice exam. This question is, what is the major product of the following reaction sequence? So they give us this bicyclic compound, and there's a bromine attached, and what they tell us is first they treat it with sodium ethoxide, which is just an ethoxide ion diluted in ethanol, and it's at 60 degrees Celsius. And then after that they treat it with ozone in Ch.8-9. I use that all the time in the lab. I can't remember what it's called. Methylene chloride, I don't know, Ch2Cl2, and then then after that they treat it with dimethyl sulfide. Alright, so the first part is an E2 reaction because we got to get a double bond here. That's the whole point, right? So E2 mechanism. It's an E2 mechanism because it's a strong base and there's heat. So here's the ethoxide anion, the sodium cation. They dissolved in the ethanol, right, at 60 degrees Celsius. So what happens is the oxygen from the ethoxide ion donates its 2 electrons to hydrogen. Oh, let me draw the molecule here, sorry. Right, so there's 2 H's here, then there's a bromine here. Right, so the oxygen donates its electrons to this hydrogen and takes it off. This bond breaks, and it gives its 2 electrons to the bond right here that's going to form a double bond, and then the bromine atom breaks off. It becomes a leaving group, and we get the following molecule. Right, and now there's 1 H here. There was 2 H, but 1 went with the ethoxide ion to become ethanol, and so there's 1 H left. The bromine's gone, and we have the double bond. So now from here, we got to deal with this, and let's just quickly go through what that is. It's ozonolysis of alkenes, and it's cleavage. It's a cleavage of alkenes with ozone, which is the O3 molecule, and workup with zinc and acetic acid. Now that's what it said on our PowerPoints, but then in the book I saw it all being done in dimethyl sulfide. Okay, that's from the book, so you can also do it this way. The Solomons and Frile book, Organic Chemistry 10th edition. So cleavage of alkenes with ozone and workup with zinc and acetic acid leads to oxidation, oxidized carbons. So if the carbon is unsubstituted, the product that is formed is a formaldehyde. If it is a monosubstituted carbon, it turns into an aldehyde. And if it's a disubstituted carbon, it becomes a ketone. And you always know that you're doing this ozonolysis of alkenes when you see ozone in methylene chloride at -78 degrees, so it has to be cold, I think, because all the examples are cold like that. And then secondly, it's treated with either zinc, with zinc and acetic acid, or dimethyl sulfide, right? So that's how you know you're dealing it whenever you see this. So that's what we have. So going back now to finish up the problem, this was the molecule that we got after the E2 mechanism. After we did the E2 mechanism, we got this molecule with the H and the double bond, the bromine left. So let's just rewrite that molecule real quick right here. Alright, so then now we're treating it, we're going to do ozonolysis of this alkene. So first we're going to treat it with ozone and methylene chloride at -78 degrees Celsius, and then we're going to treat it with dimethyl sulfide. So wherever we look at where the double bond is, and it's going to cleave there, put that like kind of dotted line. And then what's going to happen is if the carbon, let's look at the two carbons. So the two carbons that we're going to be looking at that are on the side of the double bond are here, here, and here. This carbon is disubstituted. This carbon is monosubstituted, right? Disubstituted becomes ketone, monosubstituted becomes aldehyde, unsubstituted becomes formaldehyde. So that's going to snap open. And that's going to leave us with, so here was our molecule, right? Now, the double bond was here, it broke, and this disubstituted carbon, 1, 2, this disubstituted carbon became a ketone, and the monosubstituted carbon, it was monosubstituted 1, became an aldehyde. And that is answer D on the test, on the the practice test.